We will continue from where we left off in the last video, but before that, just look for first 2 minutes. So we have arrived at that solution for I using this observation. And throughout the number system, I have made sure to use successive numbers in the number system for calculation purposes, because we are studying number systems. Okay. But there is another observation that I want to show you right now, and it is this. If you have any number system of base b, what is the range of numbers if the number of digits is n? If the number of digits is n, what is the range of numbers? So number of digit is n. So it means that there is going to be n places, there is going to be n digits, right? And each of the place, you can fill each of the place in b ways, that is from 0 to b minus 1. Each place can be filled by any one of the digit between 0 and b minus 1. Okay, so for each place you have b choices. Okay, you have b choices for each of these place. Okay, so how many numbers possible? How many numbers possible? It is equal to b into b into b into so on n times, and this is equal to b to the power n. Okay, so this is as we have seen, this is true for any number system. So if you have a n digit, how many numbers possible? It is equal to b to the power n. Okay, so this 0 and this 0 is same. This 1 or this 0 1 is same thing. In decimal, the decimal equivalent, what is the decimal equivalent of it? What is the decimal equivalent? Decimal equivalent is 0. Decimal equivalent is 1. Right? This 1 0 and this is same. This 1 1 and this is same. Okay. What is the decimal equivalent of it? It is 2. Decimal equivalent is 3. Similarly, this is again 0 and this is 1. Okay. Similarly, this is equivalent to 4, this is equivalent to 5, this is equivalent to 6, this is equivalent to 7. What I am trying to show is this. In 2-digit binary, it will include all the numbers that is there already in 1-digit numbers. 0 and 1 will also be here. Okay. Plus it will include those numbers that you cannot represent using 1 digit only. Okay. If you have a 2-digit binary, then it will, what is the range of 2-digit binary? It is 0 1 2 3. 0 1 2 3, in which 0 and 1 you can represent it using 1 bit only, and to represent 2 you need 2 bit. To represent 2 you need 2 bit. So this is the numbers that you can represent using 1 bit. So in 2-digit binary, you just add 0 to the left of it and you get a 2 digit. And apart from that, it will include those numbers that you can represent using 2 digit. Similarly, when you look at a 3-digit binary, what you have to do, you have to just add 1 0 to the left of this 0 0 and 0 1. So you can, in 3-digit binary also, you have 0, you have 1, which can be represented using 1 digit. You have 0 1 0 0 1 1, which can be represented using 2 digit. And then all those numbers that can only be represented by 3 digits. That can only be represented by 3 digits. So the range of 3 digit covers all of those numbers that is covered by 2 digit. Okay, the range by 2 digit covers all those numbers that is covered by 1 digit. Okay, why I am doing this is because we reached at this conclusion by looking at the successive numbers in binary, in octal, and in decimal, and we reached at this conclusion that this is how it follows. So this is what it is, because so far I have stressed largely in using the successive numbers to prove things, because we are studying number system, so I wanted to be sure of the context of the number system. Now in this video we have seen that a 2-digit number encompasses all those numbers that was there in 1-digit number, and all those numbers that you can represent using 2 digits only. So to get first 3-digit number, you can just think that to get first 3-digit number, you can say how many numbers are possible using 2 digits, and that will be enough, and that is b square. So we have proved this. So we have proved this observation once again using this approach. Okay, thank you. So what bn here means is that it's a n-digit number, sure shot. So if it is a n-digit number, then this n-digit number, any n-digit number, will encompass all the numbers that you can represent using n-1 digit, plus you have in the nth place you have moved from 1 to bn. Okay, from the nth place we have moved from 1 to bn. Okay, bn at the nth place represents that you have come up to this. Okay, so basically bn at the nth place represents bn 0 0 0 so on 0. So how many numbers possible? It is b to the power n-1, b to the power n-1, and this is all possible in it. This is again b to the power n-1, and this is also b to the power n-1, because in this contains all possible n-1 digit numbers. So how many numbers possible? It is equal to from 1 to bn-1, that is bn-1 into b to the power n-1 plus b to the power n-1, which is equal to bn into b to the power n-1, and this corresponds to bn into b to the power n-1. To find the value of i, this bn corresponds to the addition term, because of bn would be bn into b to the power n-1. In a similar way, you can say that bn-1 means bn-1 0 0 0 so. So what is the, so it corresponds to bn-1 into b to the power n-2, and so on. What b3 corresponds to? It corresponds to 0 0 0, that is b3 into b square. Similarly, what does b2 corresponds to? b2 corresponds to b20. Okay, that is b2 into b, and b1 corresponds to b1, that is b1 into b to the power 0. That's what it is. So basically, if you are given any number, this is supposed to be the ith number in base b, then what is I? I is equal to, you can get the value of I using the digits of this number. That is bn, you multiply it with a certain number, which is going to be b to the power n-1. Similarly, bn-1 into b to the power n-2. plus so on b3 into b square plus b2 into b plus b1 into b to the power 0. So in this case this is a weighted sum. You can say this value of I is a weighted sum. Each digit has a weightage. Each digit has a weightage. Okay. And what is that weightage? If it is nth digit, then the weightage of the nth digit is b to the power n minus 1, where b is the base of the number system. Base of the number system. Okay. Base of the number system. Every position has a weightage. Nth digit, the weightage of nth digit is b to the power n minus 1. Okay. So bn or bn minus 1 or b3 or b2 or b1, these are the digits in that base. These are the digits in that base. So that is what we call as the face value. That is what we call as face value. So face value of this is b1. Face value at first place is b1. Face value of second place is b2. Face value of third place is b3. And there is something called as the place value. And this place value is what? This place value is the weight of that place. Okay. The place value is the weight of that position. Weight of that position. So nth position, n minus 1th position, and so on. Third position, second position, first position. So what is the face value at nth position? Face value is bn. So face value is bn. What is the face value at here? N minus 1th position? It is bn minus 1. And so on. What is the face value at third position? It is b3. What is the face value at second position? It is b2. What is the face value at first position? It is b1. What is the place value of nth place? Okay, what is the place value means what is the weightage at that position. So what is the place value at nth position? It is b to the power n minus 1. What is the place value at n minus 1th position? It is b to the power n minus 2, and so on. What is the place value? What is the place value at third position? The place value at third position is b square. The place value at the second position is b. The place value at first position is b to the power 0, which is equal to 1. And so we can write the value of I. The value of I is equal to summation j is equal to 1 to n face value at the ith position into place value at the ith position. This is what a value of I is. This is what a value of I is. This is what it is. This is what it is. This is summation j is equal to 1 to n face value at j, face value at j into place value at j. Now it is easier to understand. So sorry, this is j, this is not I. Okay. So it is easy. And this type of system, number system where each position has a place is called positional number system.